So, hello, Stefan. How are you doing today?
Very well, Amy. Looking forward to this. I know we didn't get to answer all of the questions, but that's where we're getting to now. Looking forward.
Exactly. So, as a brief explainer, my name's Amy. I work really closely with Stefan in the What Store team. I was sitting next to him in the webinar, and I was looking at all the questions coming in. We had over 50 really brilliant questions. Really not enough time to answer them in the webinar. So Stefan and I are just going to go through them and answer as many as we can in the time we have. So I think I've organized them in terms of how a project goes. So I've got a bunch around planning and design. And I think I'm going to start with Zoe Mitchell's question, which was, has What Store's customers ever experienced pushback from planning departments when they're trying to get planning permission for on-site battery storage units? Good place to start.
Yeah, indeed, because I think lots of people will be worried about that. So the simple answer is actually no. I do not recall a single installation that we had, either in this life or frankly also in my previous life when we did larger front-of-the-meter batteries, where we had planning issues ultimately. Can't recall a project that we were looking at that has ultimately been declined. You may have some discussions, but in general, it's very straightforward for batteries. Don't recall a single project we looked at being declined for planning. Simple as that.
Well, that's a good, straightforward answer. There's one from Phoebe that's a kind of similar one, just asking about, are there any major risks to consider when you're putting together the business case? So when you've got these technologies on site, do we have any advice around risk management, safeties, failures of storage? It's quite a big question to answer.
Topic. Yeah. No, I mean, definitely one you need to consider, right? Because this is technology that you may not be familiar with. So I think when you design it up front, there's a couple of things to consider. So first, always make sure the design doesn't interrupt your operation on site. And this is something we have as a guiding principle. So whatever you do, we do not want to interrupt that so that it could have an effect on your business. So make sure you design it that way. Make sure you get a good warranty when you talk about failures of batteries, for example. Of course, it's technology. There could be some failure. Make sure you have a good warranty. Make sure you have a modular system where if one piece fails, the rest still works, which again is something to take into account in the design phase. And then ultimately insurance, right? So you will have your insurance company, and your insurance company will have to get comfortable with having a battery there. It is again a step where we can help with as well. We haven't seen that as an issue. So again, we don't recall an insurance company say no to a project we had in mind. Sometimes you need discussions, right? It helps, for example, that we're using LFP batteries and not NMC. So that's technological difference.
Explain that, Stefan. So LFP, what's that?
So basically an NMC battery is one that you see typically in cars that are more energy dense, but are a bit more risky, if you want. Risk is maybe the wrong word in terms of fire. So that the point whereby they get into thermal runaway is lower, while LFP, lithium iron phosphate batteries, is really what we are using. They may need a little bit more space, but are much more suitable for storage solutions on customers' premises as we do. And they have a much higher point of where they could go into thermal runaway. And I think we'll probably touch on the fire risk at some point. That's what the insurance company will ask, and we will have many layers of safety around that. And we'll touch on that. But okay. Insurance, make sure your insurance is comfortable with it. Make sure you get a good warranty. And make sure you design your system not to interrupt your business when you start at the very beginning. And then the risks are very minimal and manageable.
So I know that we worked well with Rachel in helping her sort of put together the case for what she needs to tell the insurance companies. So if anyone is at that stage, just get in contact. So we've been through this many times. I think that's the main message. Just wanted to go back to something you asked or you spoke about related to the batteries being modular. Craig Gentleman and Duncan East both had very similar questions related to the modularity of solutions. So Duncan's was, when planning for the future, are systems modular? Can you add more as you go? Is it easier, or should you oversize them now?
So yes, they are modular is the answer. So for example, batteries typically come like in rack sizes. So what we do is a typical rack size of a battery is about the size of an American fridge, to give you an idea, which is like 100 kilowatt hours. That's quite a sizable storage capacity for a smaller business already. And then you can put multiples of those down. So that's pretty much unlimited. Now, you may have a limitation if you have it in a container. Obviously, at one point, a container is full, but we do a lot of installations indoors as well, where you can design slightly bigger container up front and then add batteries later on. So that's definitely possible. And it's something, again, when you have a business, you have some growth needs that you should take into account. So that's absolutely possible, yes.
Great. Bill Jarvis had a question about private wires. So can you integrate private wire supply as part of the design?
Absolutely. Actually quite keen on that, because often you may see that the roof space available, let's say for solar, where it's typically where private wire comes in, is not sufficient, or you want to do more. And there are sites where we look at a private wire in a nearby field, for example, where you would have a private wire onto the premises. So that is absolutely possible. No big difference on the controls if you want, if it's a private wire or on the roof. But it could be very attractive for the business case if you had, for example, a bit of space or a field you can use next door to your factory or your premises. So yes, is the short answer.
That's great. And you talked about factories and premises, but John Matthias has got a great question related to community energy schemes. So is there any reason why a community energy scheme couldn't take advantage of this kind of setup?
No reason at all. Actually, quite the opposite. We see it as a natural extension of what we're doing right now. So if we're talking about behind the meter on a customer's premise, you can see the logical next step is now let's look at the wider energy community or an industrial park, for example. So we're already looking at a project where we would have 20, 30 industrial customers on a park, and we could take them fully private wire and then do it all behind one single physical meter. So absolutely, I think this is actually where a lot of the development is going to, more, if you want, like energy communities, renewable energy islands, if you want, that do most for themselves and then are connected through the grid just for specific times and may trade their surplus energy. So I think that's where the trend is going and is absolutely possible. It's the next step on our journey.
Yeah, I know we're getting quite a few inquiries related to these kind of microgrids. So we'll probably produce some more content around that.
Yeah, I think the one thing to keep in mind is it's quite a difference if you have a residential energy community or if it's a commercial industrial residential energy, just because of regulation. So residential is more protected, if you want. So you need to be able to switch your electricity supplier, which has some impact. So when you start a discussion, then make clear at the very beginning if it's a residential one or a commercial industrial one.
Great stuff. So that was all related to the planning stage of these projects. I was absolutely delighted that Douglas Blackwell asked a really straightforward question. Typically, Stefan, how large are your batteries? And Lorraine Cannell, I'm going to combine these two because one is about the size of the batteries, and Lorraine's question was about the visibility. What visibility do you have from the battery storage of the power? I mean, how can you see what's going on, and can you see it in real time?
Yeah, so first one in terms of size, as they're modular, the really smallest one we would look at is that 100 kilowatt hour system, which typically will come with like at least a 50 kilowatt inverter. So again, a 100 kilowatt hour system is kind of like a good American fridge size, something like that. And the inverter would be maybe something like this. So quite small. And then it goes up from there into the many megawatt hours. So we have done systems, as I said, from that 100 kilowatt hour range up to the many multiple megawatt hours. And this is the nice way of having a modular system, which is important, again, when you do your business case and when you size it. So literally from a fridge to multiple 40-foot shipping containers, if you want. All of that is what we have done and can do.
Brilliant. Show us an example, because I think the next question you can actually show what that would look like.
Yeah, I was about to say, so let me see if I can put this up quickly. So obviously we have an energy management system we call Podium behind everything we do. And one part of that is a lot of intelligence on site, but one part of that is showing you what's going on site, just very high level, otherwise it will take a bit too long. But let me show you how this would look like. So for example, I hope you can see this. This is a live site right now. This is probably on the smaller end, as we just discussed about sizes before, but you can see here now as a renewable system, solar in this case, that is generating 21 kilowatts now. It's a pretty miserable day here. That could be much higher. And it flows basically in here, and then you see our software then redirects that either to grid, at the moment 0, because there's more renewables than what we have consumption over here. So it will be redirected to fulfill the consumption. And then the remaining goes into the battery that is being charged up currently. And you can see it's at 48% state of charge. So our control system would look at that on a real-time basis and take into account how to direct these power flows. So you can see this literally as it happens on your site. You can also look a little bit into longer trends over here. So I'm not going into all the details. There's a lot of graphs here, but you can look at what was my site consumption, for example, how much did it take from grid? So you can see this site actually has been off grid pretty much all the time. What was my battery doing? And so on. And down here, how was my battery state of charge, for example? How is my grid supply? So this is all data that is very easily available to you through our on-site portal that we're using.
And I just wanted to paint a picture of the type of organization. This is essentially, in my mind, I haven't been to the location, but it's a big farm. It's got a significant roof space. The solar panels are on the roof space. Yes. The batteries are in one of those fridge type racks in a corner of one of the warehouses. Mm-hmm. We've got an ECD that takes the information and plugs it into Podium.
And control device, by the way, it's the small controller that goes on site.
Yeah, so I just wanted to paint a picture because it's I love seeing that visual. The simplified visual just kind of gives you everything you need to know, really. So we've talked about the design, we've talked about the EMS Podium. Let's have some questions around post-commissioning, or once you've actually got this system in place.
Yep.
Zoe Mitchell was really keen to know who manages the ongoing maintenance of the solar systems and the battery storage system.
Yeah, always critical. So there's several options. So we offer that. If you wanted that from us, then we can do it. We will always do kind of like, if you want at least the second layer of support, because we're obviously the ones who supply the system. So you can have us to do it all. We have partners in the UK, which have a lot of engineers all across the country, which can do that for you as well, if you want, and then come to us for any more difficult questions. Or what we see quite often is if you have, let's say, a solar installer that does the EPC, the full turnkey project, if you want to call it that way, then they would do it. And again, if there's something that they can't do, they will come to us for backup. So there's a couple of options that you can take on there.
Great. And what are the technical constraints you might face when you've got a larger scale installation?
So because it's a modular system, if you go very large, it's basically just a multiple of the same thing, right? So if you go large, let's say we've done quite a lot of 40-foot shipping containers. These days, actually 20-foot containers are very suitable for most applications. So you can put one of these down, or you can put 4, 5, or 6 down. That doesn't really change anything in terms of the technology or the controls or anything alike. The main thing, besides having the space available and maybe planning, but that's not really an issue, as I mentioned, will be grid. So I think the grid connection is what will be the biggest issue. So if you want to put batteries down on your site, like solar, for example, that counts as new generation. So you would have to apply, even if you don't change your grid import and export size, you have to apply to grid, the DNO, your local DNO. And it could be that they have constraints in their area and say, sorry, you cannot do that scheme as you had imagined. It needs to be smaller because we cannot allow more. We see this. This is quite common. And I think I mentioned in a webinar briefly as well that we do have solutions to get around that as well. It's this famous DC connected systems, but there is a way that if grid comes back to you and says, sorry, you can't do this, either solar or battery, that we can get around it with the right technological solution. Yeah, I would think grid is the main constraints if you really scale up, but again, one that can be addressed with the right design.
And I'll probably send a link related to this DC coupled solar solution we have to overcome the grid constraint issue. So just another one from Daniel Farris. This is a good question that comes up all the time. What percentage of the battery's performance is available after the 10-year warranty period?
Sorry to say, that depends, right? So basically, you should look at a good warranty, as I said. So ours come with 10 years warranty, for example, and there's always a cycle life there as well. In our case, I think I mentioned it's 7,300 cycles. So in the 10 years, what comes after really depends how you have used that battery in the 10 years. So if you, for example, use your 7,300 cycles and you do 1 cycle a year, that's 20 years you can cover, right? If you do 2 cycles a day, which is unusual, then you get to 10 years and you would still have life in the battery as well. So our warranty, for example, goes down to 70% of the initial capacity. So once you've hit your 7,300 cycles, full charge, full discharge, 7,300 times, then you would still have at least 70% of your initial capacity in the battery. And you can usually use the battery a bit more, not to 0, that's not how it works, but somewhere to around 60% potentially until we have to replace it.
So it's essentially a bit like the battery in your phone. You know, you get full charge for quite a while, and then it tapers off towards the end of it.
Yeah, much less in real life. I mean, the batteries, we probably all know our mobile phone batteries after 2 years or 3 years. That's quite different with the systems we have because they're much larger, and the way you charge and discharge them, you manage in a smarter way. But yes, after you will see a degradation. So I said, if you do 10 years, 2 full charge and discharge cycles every day for 10 years, you will have 70% of the initial capacity still there, and then you can go many more years. So typically with the projects we see, you probably be somewhere around year 17, 18 earliest when you need to look at replacing some of the modules, not the whole system, right? Just the modules where you store the electricity. Some last longer, 20, 25 years. Really depends on how your charging cycles look like.
Yeah. And then a question that comes up all the time as an addendum to this one, Adrian Balcom picked up, what is the recyclability of the used batteries?
Yeah, that's something that is obviously important. So we are signed up to a recycling scheme as a company. As you can imagine, this is quite new. Batteries are around about 10 years when I did the first one. So there haven't been really a lot of recycling yet. But you also see a big recycling industry springing up. And actually in our parent company's wider portfolio, there's also a battery recycling company that could take these batteries. So what I see happening is, although we are signing up to a recycling scheme, I really expect that in 15 years plus, when you may look at the repowering your battery, there will be people paying you to take this off you to recycle the lithium, for example, out of it, or other valuable materials. This is already happening now, and this will only increase as we see more batteries coming to the end of their life cycle, particularly cars as well, right? The main use will be in cars.
Yeah, it's interesting, isn't it? Because batteries are still in the phase of development. And there are all sorts of different, we've got the nickel cadmium batteries, LFP batteries. There's actually a question here from Mike Goodfellow Smith that brings up sodium and asks, is sodium likely to feature more strongly in battery solutions?
Yes, and by the way, before I go into sodium, maybe just to explain quickly as well, we talk about this LFP, NMC battery type. So I mentioned before that we use LFP, lithium iron phosphate. It's important that there is no cobalt, for example, in there. So lots of people are aware of these cobalt mines. You hear a lot about Africa and the bad conditions. So this is not something we use in the batteries we use. So it's just lithium and other metals that are very common. No problem on the cobalt side. On sodium, yes, I'm quite keen and I keep a close eye on sodium batteries. So there are sodium batteries coming out right now. Sodium, literally table salt, right? To be clear, no lithium. Literally replaces the lithium in those batteries. That is on one hand cheaper. So I would expect somewhere around 20–30% overall cost decline. It has not the same performance characteristics as lithium. So lithium is better as a material for energy storage. So you can see with a trade-off coming between the performance and the cost. What we see in the market now is, yes, you see the first applications coming. I know there are, for example, these small motorcycles in Asia starting to be powered with sodium batteries. It is definitely an alternative. I think, in my mind, it is an interesting one. If you look at the battery supply chain right now, a lot of people, a lot of large OEMs have invested a lot in developing the lithium-ion supply chain. So if you want to switch to sodium, which is technically actually not that complicated, that is a bit of a step for them. So a lot on this hinges to me like what the price of lithium is going to do. So if the lithium price is going up a lot, then you will see more sodium, because then the price difference becomes more important. If lithium stays relatively low priced, it has come down a lot over the last 1 or 2 years, then we probably see lithium remaining more dominant in the chain. So for us and for you, yes, it can come. It is good to have that as another solution to really keep like that lithium price in check. Long answer. I hope it explains a little bit what's going on in the industry. So definitely sodium batteries work, right? No question. They are there. They have other advantages, by the way, not just cost. But they're not to the level as lithium yet. But I think we will see a balance between the two, where you see both solutions in the market in the next few years.
That's a great response, Stefan, because I think it's a complicated, interconnected supply chain issue. So it's really good to know that there are multiple different routes that we can take over the next 10, 25 years as more batteries are adopted. Just keeping on this kind of commercial focus, I mean, bringing it down to the individual business cases for each of these organizations. There's a really specific question related to P415 from Robert Thrift that says, can this kind of P415 opportunity be of benefit to a small solar farm, like 3-acre solar farm?
I assume that's just the solar, nothing else. So if it's just the solar, I don't think so. Maybe to some extent where you can switch off the solar, but mainly not, because it will be mainly for enabling trading. So like helping the grid balance the supply demand imbalances. So maybe moving your solar consumption from when you have it to the evening, as I mentioned. And for that, you really need a battery. So if you can't control the assets, then you're basically a bit at the mercy of the sun, or the non-sun as today. So don't think a lot, unfortunately, to be honest. You could add a battery, and then you could have a hybrid system, which we see increasingly happening. And then, of course, you can absolutely benefit from P415.
Yeah, well, maybe this question from Craig Gentleman is really it's a good addition to that, or you could go deeper. He asks, is charging directly from the grid at cheap periods, like at night, and then using it during the day, something that's popular and demonstrable in terms of payback?
Yeah, I'm sure it's popular. I mean, that's part of our overall functionality. And there are different tariffs. So if you're on a day-night tariff, then we would take it into account. We have customers that are on a fully dynamic tariff, by the way, for example, where you really follow like the market price. Then you can benefit even more. So this is something that actually I think is a very good solution if you have a solar battery system. So yeah, absolutely, it's popular.
There's another question related to, payback cases, tariffs. Chris Cook asked, adding batteries is a higher upfront cost than just solar, but as illustrated in the webinar, it gives the ability to save on electricity through time of use tariffs and smart exports. So what's the guidance on how payback cases change with the addition of batteries? I mean, these are all very similar questions, but it gets to the heart of like the value add, what we're suggesting.
Yeah, absolutely. I mean, it is a fair question, right? How does the business case look like? And as I mentioned, this is one you need to establish very early on. So simply said, if it depends a bit what metric you look at, right? If you look at net present value over the lifetime, then a battery and solar system are always better. Right? If you look at pure payback, then, for example, what we typically see, if you have a solar system that is just designed to cover peak load in summer, so it doesn't benefit from, let's say, an overbuild and moving the solar load around with a battery, then those typically tend to have lower paybacks than a battery and solar system, just because the capex upfront is lower, right, which gives you a quicker payback. If you have a system that has slightly more solar than you can use on site, and you have the ability to move it around, to trade, as we just said, to take advantage of those tariffs, then typically the payback of solar and battery together is better than just solar. So as always, it depends is a bit an unsatisfactory answer, but hopefully it gives you some idea about the different steps. But typically when you look at net present value or total lifetime costs or benefits of your system, then adding a battery always makes sense. If you're just looking at payback, then a lot depends of how you size your solar and how much benefit you take from it. I said, if you just size it just to get peak load covered in summer, then you probably have a better pure payback on just solar. But of course, you don't cover all your load with that solar system.
That's a great response. And I think there were a lot of questions in this section. I think you've answered Roderick Houston's, because he had very specific questions related to what's better for export tariff, what are the returns for solar PV versus battery? And the simple answer is it depends, and it changes in every single case.
It does, yeah. And sometimes just solar is okay. As I mentioned, really be careful with solar cannibalization. This is really something that is only going to get more extreme as we go forward. But you can always ask us, right? I mean, as I said, we have this design team up front that helps you look at the business case. And there have been cases where we say, no, battery doesn't make sense. And we would do that.
Yeah. And I think my final question, actually, because this is a really good response to this whole section, but Camille Plessis had a very specific question. She wanted to know, does solar cannibalization still apply to a customer that has a fixed solar export price contract with its supplier?
Yeah, as I pulled up on the acronyms there, right? So as long as you have a fixed export PPA for your solar at a good price, no, then you have that fixed supply, and that is good. What you will see happening is that that fixed PPA price you get for exporting is going down and down and down and down and down. And at some point will be very little, just because of that solar cannibalization. So if you have one right now at a good level, by all means keep it. But you will see when you probably want to renew, that level, what you get, will keep going down a lot because of that solar cannibalization.
Yeah, great. I think most of the questions that were asked have been answered in some form or other. I just want to say thanks, Stefan. I always love having conversations with you related to this stuff. I mean, your kind of depths of knowledge are great, but once we actually dig into the detail, a lot of the responses are, it depends in every case. So it's a challenge trying to apply any universal answers. And I guess my sort of response to that is, anyone who still has questions after this, after the webinar, we're going to put all of our details. I have the pleasure of working with a brilliant team who have multiple years of experience in this space. So if we can't answer your question, well, I'd be really surprised. So yeah, thanks, Stefan. Thanks everyone for your questions, and yeah, have a great Friday.
Yeah, thanks a lot. Enjoy the long weekend.